Hi everyone. In today's lesson, we're going to talk about the limit definition of the derivative, with polynomials specifically. But before we can get into that, we need to review slopes. We can find the slope of a line between any 2 points using the following formula. So you should have seen the slope formula denoted with the letter m as change in y over change in x. This triangle means delta. Delta means change. So change in y over change in x. And the formula is y2 minus y1 over x2 minus x1. So if I look at this example here, it doesn't matter which point, whether this point or this point, that you make the y1 and the x1. So let's just say we make this the first point. So I'm going to call this one x1, y1, first point, and then call this one x2, y2. And then I'm just going to plug it into the formula. y2 is 3, and y1 is -1. So 3 minus -1 for the y's. And now for the x's, x2 is 4, x1 is -1. So 4 minus -2. Double negatives will give us 4 over 6, which reduces to 2/3. So that's the first definition of slope that you learned maybe in Algebra 1 or even geometry. But then we can talk about an average slope or an average rate of change between 2 points on a curve this time, rather than a straight line, right? So average rate of change is the more advanced way that we say slope. So if we take a look at this example here, we have a curve, right? It's not a line this time. And I want to take the slope of any 2 points, right? I didn't specify which ones. Let's just say I want you to find the slope between the point 0, 3 and -2, -1. So take a couple minutes, pause the video, and find the slope between those two lines. And then hit resume when you're ready for the answer. All right, this is what I got. So I decided to make this point x1, y1 and this point x2, y2. So what you just found is the slope of the line that joins these 2 points. So we like to call this a secant line. If you remember from geometry, you learned a tangent line and a secant line when we had circles, right? So like, let's just say you had a circle and you had a line that went through like this versus a line that went through like that. This is a secant line because it hits the circle in 2 points. And this one is a tangent line because it hits the circle in 1 point. So we're going to use these two same vocabulary words, but for functions instead. So because this line hits the curve in these two spots, we say it's a secant line. So more advanced, we talk about average rate of change instead of saying the word slope when I'm asking you to find it between 2 points that make up a line. All right, so now what if I ask you to find the slope at 1 point on a curve? This, by definition, is called the instantaneous rate of change, or in other words, the derivative, new vocabulary word here, which is also referred to as the slope of the tangent line at a particular x value. So let me explain what all of this means. So let's just say we have an xy axis here, and we have a parabola like so. Now, just to prove the formula here, let's just say this value here is x, and this value over here is h units away. So we could call this x plus h. So if I go up to the point, the curve, it would be here and here. So my x value in this point is x. So we don't know the y value, so we could just call this x comma f of x. And then over here, our x value is x plus h. I don't know what the y value is, so I could say f of x plus h, and those would be my 2 points. Now, if I wanted to find the slope of the secant line that's between these two, I would just do change in y over change in x, or make this x1, y1, x2, y2, and we can find our slope. And that would be this secant line. But I don't care about the secant line. I want to know about the slope at one particular point. So what about that? Let's just say this particular point isn't this the line at this particular point that is tangent, right? So one particular point to the curve is called the tangent line, and the slope of the tangent line is defined as the derivative. So the notation that we use for derivative is f prime of x. So this means derivative. And derivative is the slope of the tangent line. So in order for us to be at this tangent line, this distance at h can exist. So we have to have this distance be 0 so that the point is on top of each other. So we will say the derivative is the limit as h approaches 0 of, now let's look at the slope formula. F of x plus h is your y2 minus your y1, which is f of x. And on the bottom, we have x2 minus x1. So x plus h minus x. And in the denominator, the x's will cancel. So my derivative, f prime of x, is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. Now, I just proved where this came from. If that was a little confusing for you to follow, that's totally okay. We're just going to use this formula from here on out. All right, so now what I'd like to do is use our derivative, which is the slope of the tangent line. Here's the formula that we just derived. I'd like to use this to find the derivative of this problem. So we have to start by writing neatly. Being neat here will be your friend. So f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. So what we need to do is two separate things. So I'm going to write it again. So we've got f prime of x is the limit as h approaches 0 of f of x plus h. So f of x plus h will go in here, minus f of x, which will go in here, all over h. So this first part, f of x plus h, what that means is we're going to put an x plus h everywhere I see an x. So 2x squared, this x will be replaced with x plus h, and this x will be replaced with x plus h. So we've got, I'll use red, I've got 2x plus h squared minus x plus h plus 5. So notice I did 2x plus h squared minus x plus h plus 5. Now this f of x means this, my original function. So I'm just going to subtract 2x squared minus x minus 5. And these brackets I put here to show you the differences between the two things, and also to remember you will have to distribute this negative. So this simplification must be done first. Obviously exponents before we multiply. So I'm actually going to do the x plus h squared on the side here. X plus h times x plus h. So x times x squared. X times h, xh. H times x, we could write that as xh. Multiplication is commutative. And h times h is h squared. These are my like terms. I've got two of them. So x squared plus 2xh plus h squared. So we have to multiply that by 2. So let's keep writing down neatly. We have the derivative f prime of x is equal to the limit as h approaches 0 of 2 times x squared plus 2xh plus h squared minus x plus h plus 5 minus our 2x squared minus x minus 5 all over h. So now we can do a lot of distributing. We can distribute the 2 the negative 1 here and the negative 1 here. So we now have the derivative is equal to the limit as h approaches 0 of 2x squared plus 4xh plus 2h squared minus x minus h plus 5 minus 2x squared plus x plus 5 all over h. So now we actually can probably cancel some things. Notice that I have a positive 2x squared with a negative 2x squared, a negative x with a positive x, and a positive 5 with, this is actually supposed to be a negative 5. I noticed I typed that in wrong. Sorry, this should be a plus 5, so then this would be a minus. So all of the stuff on the right is supposed to cancel. If it doesn't cancel, that means you did something wrong. So what are we left with now? Well, let's see. So we have the derivative is the limit as h approaches 0 of now 4xh plus 2h squared minus h all over h. So to divide all of these, we're going to divide each piece individually by h. So here the h's cancel. So we have f prime of x is the limit as h approaches 0 of 4x. Now here the h's cancel, but we're still left with 1, right? We have to subtract the exponents. So plus 2h. Here, any h divided by itself is negative 1. So now we can actually take our limit. So limit as h approaches 0 means we're going to use direct substitution. So directly substitute now for h. So 4x plus 2 times 0 minus 1. So 2 times 0 is nothing. So 4x minus 1 is now your derivative, f prime of x, is equal to 4x minus 1. Now, what this derivative can tell you, it can tell you the slope of the tangent line at any given x value. So if I want to find the slope of the tangent line at x equals 4, all I have to do is take my derivative function, 4x minus 1, and plug in 4. So 4 times 4 is 16. 16 minus 1 is 15. So this is the slope of the tangent line at x equals 4. All right, that's it for today. If you have any questions, now's a good time to jot them down. Otherwise, we'll see you in class tomorrow. Have a good night.